See ya. God, I hope that's going to be readable. What's that? How do you do what?
Make one.
You can grab the graph anywhere, grab it and slide it around wherever you want it. And if you want the ones to show up, it's under the settings here. You just have to put it a 1 there and a 1 there. Is that better?
Yeah.
Yeah, you can just grab the graph and move it around anywhere.
Okay.
What's that? Well, it was the assignment that we did when you were here. I mean, if you want to get points for it, you can get it done. You have to come get some help sometime. Come to my office hour, always works great. Hey, folks, I got stuff for you over here. That away. You can use your calculator or the Desmos calculator to get help with that. Here you go. Have a white. Grab some paper. 3 pieces of paper. Lucky. Wish I got 3 pieces of paper. Well, nobody's giving me paper. I had to do it myself.
You want mine?
Maybe. Let me think about that. If you give me yours, what will you have?
No paper.
Mr. Beck, you been on the golf course at all?
I just had Rick and all them.
No home run today. Home run tomorrow. Wait, Max, come back. Fine. Grab one of these. Grab a piece of paper each. I'm sorry, Mr. Beck, I didn't hear you. What was that?
I said me, Brady, and Rick, and a bunch of other people.
And how did it go?
Yeah, we'll see.
They did good. No shot.
No shot with
Paperwork,
what?
one of each. Paperwork, one of each. Hey, you're back. I'm back.
Excuse me, can you explain that? No shot with what?
No shots
I don't get it.
to earn a passing grade.
No, he's talking about something else, but I don't know what he's talking about.
Oh, really? Let's hear it. Sounds intriguing. No
Explain
shot
yourself, Wesley.
at a
For
prom
the
date.
whole class now.
Yeah, something like that.
No, wait. Can you repeat what you said?
I said no shot at a prom date.
Ooh. Wait, me or Zach?
Huh?
Oh.
What? No comment.
Wait, what?
Yeah.
What?
Put him on the spot and he stays real quiet.
This is fun today.
Talking to Lawrence about golf.
Yeah?
That's one way.
There's paperwork over there, man. There's 3 of them.
Okay, I'll come back to that.
Okay, sounds good. Something about golf. I heard golf.
Whoa.
Lawrence.
Yeah, I was talking to Lawrence because I'm the only one signed
know
up in the office,
You're right.
but I was like, is there anyone else? And he was like, oh yeah, I'm just trying to get other people to come too.
Good morning, Mila.
Good
morning,
Olivia.
Oh, why am I so close to
What notes do I?
So that's not the other day.
You said
A
that.
week ago.
Did he comment about the chair?
Yeah, he said.
Like
why
the chair
is
feels
it
more
so
comfortable
small?
today. This chair
It was
is.
smaller.
This chair was lower today.
Yeah.
super low?
Okay, super low. Like low rider one.
Yeah.
My brother modified his car and it's a lowrider pretty cool.
It's pretty cool.
It like goes up and down with the little
Got the
machine.
power in the shocks
Yep.
and everything.
What time is pictures?
And I-
I don't even.
Well, that was a wise investment.
Well, it was an old car that my dad had gotten like when they got here from Mexico. And then they kept it. He always said that he wanted it, and so then my dad kept it for him, and
I
he
understand.
made it all cool, but he doesn't really take it out.
Okay.
What time are pictures? Do you know that?
After
That's
6 years.
that's after 6 end of the day today.
So like
There
T3.
won't be a T3 6 period.
Oh, I
There'll be
gotta
we'll
come
get your
back.
pictures taken care of.
Okay.
And it's not your yearbook pictures. It's
No,
like
it's just the ASP.
ASP pictures and stuff. Yeah. For the system.
I gotta do that.
Yes, 6th period. Everybody's got to get picture in.
I just don't have a 6th period, so I have to leave and then come in.
Let's see. Are we missing anybody else, or the gang all here? Dun, 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 dun. I guess I could do this, and I could just find out myself. Still no Harmon. Max. Oh my God, you're here. What is up?
last one.
You even have notes and stuff, dude? You got nothing? You got nothing. I'm the last one in the door. We can make it.
What, did you have the notes from the day's meeting?
Hey, folks, first thing you want to do today is make sure you dig out your calculadora. And you should have a piece of paper that says Extras Ractus on it. It's extra practice with Z's. Get it? Extra practice with Z's. I think that's funny. All right, that's me. I think everything's funny. Did you get paperwork here, dude? It's all right over there. I have extra notes packets here somewhere. What did I do with the extra chapter 7 notes packages? What? Are you being a smart aleck over there? Are you being smarky?
I said you gave them to me.
I think they're in the back.
I think they're in the back there. Oh, they're fine.
See, that was more helpful.
Yeah, that's helpful. Okay, I don't know that I have one. I might have one.
Huh?
I'm sticking my tongue out. I don't know if I'm-
Hey, look at that. They were in the back. Somebody was helpful. This is chapter 207 notes.
Feeling a bit of hostility coming from the front of the room
Front of the room? Is that me?
and Mabel.
Oh.
Not naming any names though.
All right, folks. So anyway, it's this piece of paper. It says extra practice with these. Extra practice, extras practice. Hey, dive on in. See if you can do these. You're going to need to use the z equals x minus mean over standard deviation formula, inverse norm and normal CDF stuff in your calculator. Hey, do you know how to do any of this? Bummer. That makes life rough. You're like the guy who goes to a knife fight without a knife, aren't you? All right. This is you're not going to have the first clue on how to do that, so just do that. My notes? Hey, look, your notes. You're welcome to copy them all. Okay. How are we doing?
Are you confused? I know.
It's this way.
I did not.
It's the same one there and there. We used over and over.
Since this was
What you're gonna do? What you're gonna do is you're gonna
I
find this
put it in
score
that
over here,
little
we call this
equation
SAT
thing,
world.
I don't know if it's right.
And then you're gonna use that
What
score
one?
over here. in Z
Well,
world to get a
yeah.
score what's-
I don't know if that's.
So get a Z score over here first for the SAT. They want the information you know. Oh, I like what I see. Did you get a Z score?
Okay, so that minus that, is that really 263? That minus that over that?
No,
I think you screwed up just a little bit. And they have SAT score, there's a mean of 10.6.
Oh, it's
That's
two-
not 20.9, that's the standard
Yeah,
deviation that's underneath.
no, I put 20.9.
Yeah, that's not the right number. Okay, so you need to get a Z-score. We're gonna have SAT world, okay? SAT, over here, we're gonna have ACT world. There's a situation you can talk about for a score, 1287. Get a Z-score for that 1287 over here. Then we'll do these, over here. Start here, get a Z-score for 1287.
So to get the Z score, I'm gonna use.
X minus mean over standard deviation. Just like that. Okay, these mean, the standard deviation, are not for the SAT, okay? So this is the SAT score. Okay, the mean and standard deviation for SAT are right there. Those are the two numbers. on that one. How you doing? All right. Did we get that? Inflation? I like it, I like it, I like it. You're right, you're gonna get a Z-score here. And then we're gonna use that Z-score here on this side for the SAT. That's perfect. That's gonna be the right Z-score. With the mean over here. But this SAT, this is SAT. You're getting this number right there, right? Once you know that number, then you can come over here, and you use that same Z-score here, and then figure out this.
Will be seven.
That number is right in the box. Whatever goes here.
Yeah, I know, but X is 1287.
Perfect. 125.
Oh, yeah.
That was my question.
I bet you wanted to answer.
So we really want to look and figure out what number
Yes, but no.
125 above that mean, once it uses a different mean standard deviation. it's less than that. So we use the same equation. Not finding the one that's missing. Okay, no, dude. Okay, that's perfect for the SAT, right? Now we're gonna find the equivalent ACT score. You're gonna,
Oh, sure.
we have this equation, right? We're gonna use that Z-score there. But now we're gonna use
I never know
that
what
one,
one
that one,
person is.
there, and there.
I don't use the calculator, I use the yellow sheet.
Okay? How you doing?
Right.
Oh, sorry. This is X minus mean, right? The 10.6. That's the mean. The X involved right here. is 47. That's the score you're being told. Which of these is SAT world? Okay, so this is SAT world, right? This mean is 10.6. You're being told the score of 1287, which is over here somewhere, right? Okay. You are calculating the Z-score. And you just got to put 10.6 or 1287 right there. Whatever you get for a Z here, or whatever. Then we're over here, and we're going to put that same Z-score in the same place. This has a different meaning, standard deviation. This is a meaning of 1.9, and it's going to be the plane. So we use the same equation. That's my answer. We're still going to that Z-score, one over that, right? One over mean. And one over standard deviation. We'll be able to find that X, which is the equivalent of ACT for that SAT. Okay? How you doing there, Bob? So, where you at? I don't have a clue what we're doing, I'm not dealing with it, I don't know nothing, or you're doing something. Okay, so, I actually finally, today, started, I watched that video for all your video on, I only went to try, and notes on, so, for the most part, I was just worried about copying it out today. Until we get to, right over here, where we start calculating these scores. That's kind of what I think. It's the same thing. But this is something that I want to enter because no more. Hey, if you get an answer for the first one, you want to know if you're right, let me know, I'll tell you if it's correct. Right there?
Okay. And then wait, is this right? Is that how it's supposed to do it? Use this?
Yes, yes, you took that, use it over here, and that's, that answer, yes.
Oh.
That's perfect. What's up? The standard deviation for the SAT, is 209. That 4.8 is for the ACT.
Oh my gosh.
Okay.
Okay, we have two questions. First, I have a hard time figuring out what goes into the word effort, so.
Lower upper, okay, so did you, let me see, you got a Z-score, right?
I just put those because that's.
So this is one where that's not gonna do it, you're gonna need to use the equation, like you did right here. Can I scribble all over your paper? Okay, this is the SAT, right?
Yes.
We're trying to figure out the ACT score right here. We're gonna use this equation. Z equals X minus mean equals the standard deviation. That's the equation right there, right? Okay, this Z score is right here. The mean is right here.
Okay, I didn't know if I could have a center, since I found a standard deviation.
Once you get the Z score, and then the standard deviation for the SAT, that's right there, 4.8, goes right there. You'll know that one without knowing that one. You're trying to find that, which will give you the equivalent ACT for that SAT score.
Okay, sounds good. Thank you.
What's up, Bob? Okay, so this is not gonna work on this one. Now I'm gonna do, okay, this, the way you're using this part, you're trying to equation isn't gonna be very helpful, that's the right Z score. Okay? What you're gonna do is, you're gonna use this equation. Right? The Z score. So 1.4, right there. This is the ACT that you're working on now, right? The ACT has its own mean and standard deviation, so over there and there, and you solve for that. Hold on. Hey, that's correct answer. So you're right, you have a Z score. Okay?
He knew.
So that,
We
this,
did
this
this again.
score 13 is higher than the average. The average is 1287.
Not
That's
on that.
somewhere over here, right?
Oh, you say you didn't.
You're looking for that percent mark right there.
Oh, what are you?
Okay, so how do we get from this is Z score up to
You guys-
infinity? 1.39, we'll add, use it, almost equal.
I did solve for X, so solve for
And
Z.
here, almost equal.
X is given, 1318.
Distribution is right
Nothing?
above the average weight, second.
Is it times,
Yeah.
you find variation times Z plus the mean?
Yeah.
You're going backwards on that equation,
You see
yeah.
this range here?
Is it plus?
This is the lower.
Like how you do it?
Yeah, like you know what I'm talking about, like the Z equals.
Yeah, so what's the first step?
So it's, if
Z
you're going
equals-
backwards to find the X, it's standard deviation
And then upper
times
is
Z.
just- what's a lot of
plus
standard
three.
deviations? 10, 20,
Yeah,
Yeah.
yeah.
that's a
Okay.
big number. There you go. Okay,
Luckily you didn't answer my question.
Oh, it's number one.
it just aired out there perfect.
You're on
Put it on the face.
I finished.
Get it?
It's
There it
26.
is. Correct
Yeah,
answer.
I asked you, but you said,
Whatever
you
you
said one or something.
Oh. Then
Oh,
once you
this-
get
the Z
8%
square, that
there,
was one
that means this is
flat.
the
Yeah, I didn't need
90%.
Okay, and then the answer I got
I
was,
already got the answer. I asked her.
okay, then,
Yeah, because we were trying to find.
I'm on number.
The better way to have done that would have been, so go back to the distribution then. Achieve normalcy at the end.
1, 3, 1, 8, 9.
So we should have gone from negative infinity. and this should have gone up.
1, 2,
So like negative whatever. Negative, negative. Yeah, just make it more than like 4 or 5, that's good. And then the upper would be 1.397.
Oh, the sunflower.
And that should tell you. What's up? And on the game. So that times that plus that. Okay, 4.8 and 1.24. I believe that. The 1026 plus that right there. The AC plus 1. Oh, you use it's not 1026. For AC, you use the.
Okay, I'll
Erasers, yeah, that's good. We have erasers in there. How you doing?
oh, is this how I'm supposed to do that?
Yep.
Okay, so wait, I have a question just to clarify, when I'm using, wait, no. when using normal CDF,
So like,
Yes.
if I,
this can be anything.
so the lower has to be.
No, no,
anything
no, no,
necessarily.
below.
So,
Below.
Because the upper would be the Z-score, right?
just a second.
Okay, so I can
Yeah,
make
those
that.
kinds of things.
Okay, here's 13 over there, right? We're looking for this person's percentile.
Yeah.
How much of that is shaded in?
The
The lower is way off towards negative infinity, the upper,
So would the upper be anything above 1,000?
so the lower would be like negative 10 standard deviations. The upper is 1.39 right there.
Okay, so the upper is would be the Z-score.
Yeah, yeah, this is perfect, and then paste that in.
I got
That's
zero.
right.
Okay, perfect.
I just rounded to 92.
No, I don't think so.
1.27.
That's not what I.
Okay.
What did you, oh, I have to put the me in.
Okay, next.
Or-
Good answer. Hey, what's that? Totally never easy stuff. Okay, so that's why I draw the picture. Because, okay, what does that mean? What is it? What's the meaning for this? What is each person's score and what does that have? Way over here, right?
Yeah.
Okay, where's the
And for
percentile?
problems,
That's
Because it's lower than.
this area, right?
And then for the upper, it's
Pretty hot.
But I'm not
It's
sure.
probably in the 90s. Okay, well, how do I get, now that I know
And then
this,
for
that's a
the,
score
I mean, if the ones that are just.
1.397.
Oh,
How do I find out the area from negative infinity?
The row, wherever it's at, or the 209.
Once again?
But I'm not sure.
what did you get for your percent?
The lower would be some negative standard deviation way over there, like negative 100, negative 1 billion. That works. But on this side, you got nothing at that 100. Yeah. That's not necessary. Next. Check. Ooh, what do you got? Oh, that's your picture so far. Nice, nice. So 25 and 75%. Could be 55 right here and 75 here. You know, we can do that. There you can just be easy source. Nobody looking for percent to or easy source. Right backwards. How are we doing? This is the right Z score. Okay. This 10.6. Right. This person's out of what? 13, next probably vision. That's like there, right? The question is, what is this person's percentile? How do you feel about this person?
For number 2, yeah.
What do you think their percentile is?
Oh, like the upper and lower.
10%, 20%, 80%,
The upper
90%?
is,
Pretty high.
okay, so you see this,
You're looking for.
all of this, what you're trying to figure out, so this is the upper, so you
There's
must
Z
go up to
score right
10,
here.
and the lower, you put in the
One,
Z-score that you use.
Oh.
So for the, no, I have that backwards.
you're going from negative infinity
So the lower is.
to there.
The lower is the, like, up to 10 standard deviation, and the upper is your Z-score that
From
you
the
put in.
low to the high, the low is negative infinity, the high is 1.39. It'll tell you that's How we doing?
Pretty good,
I like your diagram.
thank you.
Even better, I
Do I
like
have
the
to
answer.
color it in?
So the only thing I would say is on this, there's a question, what was her percentile?
Mm.
I can see all your work, but I don't know that I see it.
So what do we get?
What is it?
-1.9.
Do I?
99?
90 seconds?
All you need to do
0.7.
is just take a pencil and give that flare.
Okay,
You know what I mean by flare?
Yeah.
Do you like to work flare?
I don't know.
Flame?
Maybe.
Does that work?
That pause.
Yeah.
Yeah, I can see, that's my answer,
Okay,
as opposed to, it's just a whole bunch of random.
Yeah.
that makes sense.
That's perfect, that's awesome stuff.
This one I'm a little.
Number 3,
Mhm.
okay, we're gonna draw out everything that we can, just like you've done on the other problems. I love the way you fill in your diagrams correctly, it helps me to understand what's going on.
Yeah.
Okay, so are we talking about SAT or ACT here? If it's ACT, there's something I can put in this center. Yep, right there. And I know the Z-score there, and I know the percentile.
So nice that that's the same.
Every time. Quartiles are the distribution of the values in cumulative proportions of 25% and 75%. Where are 25 and 75% in this?
Here?
Well, This is different.
Oh, wait, percent.
You go like a quarter and 75 cents.
So I'm gonna do like
There and there. That's 0.25 and that's 0.75. What we're gonna do is we're going to go, here we were looking for numbers down in percentiles. Here we're gonna go from percentiles back up to the numbers. That's what we
Yeah.
I know how to turn Z to a percent. You're gonna do inverse norm 0.25 and inverse norm 0.75. That'll give you Z scores here.
Use this equation to.
Yes.
Okay,
You have to use it twice.
thank you.
What's up?
I need help.
You did one high five, right?
That was with my hand.
Or are you saying
I was
peace?
just raising my hand.
You made
for
American
help
peace, brother. Oh. What can I help you?
on number 30.
Okay, so the first thing I'd like you to do is decide, what kind of problem is this? Is that ACT, SAT, what's going on? It's an ACT problem. Okay, you know what number goes right there? I'll be there in a minute, Max.
0.
For the last
Okay.
one.
Oh.
So we're on the-
Oh, the raw is like
I'm
the
pretty sure
wrong
you
line.
do the
The raw scores are just raw scores. They're ACT scores. It's the mean ACT. That goes right there.
Yeah.
You use
That's
the,
the middle or the mean
so to go from.
number.
Yeah, no, I'm gonna go back.
Okay.
You know what the Z
So
score
you
and
just
percent
do
are right
that, and then you put 0.25 in the area. And then we get that, and
there? Yep.
then I just
What's the percentile if you're at mean?
use to get the X, because that's what.
What percent is it filled from here?
I'm really
There.
confused.
Okay, wait, what?
50.5.
Where are you
Perfect.
lost?
Okay, read me this sentence on what's going on.
The analogy.
Okay, well, it's all confusing, but like, okay, do you get
Where are 25%, 70%? This is 50%.
like where the 0.5 and 0.75 is?
Sure.
Okay, we'll do just the numbers that they give
Yes.
you, pretty much where you start.
Yeah.
Starting point, right? So you need
Yes.
to find the Z
Glory,
score.
hallelujah.
0.25.
We're
Because
looking
you
for
need, the
that
equation
number.
that you're gonna be
and that
using for the most part is
On
the
this
Z
side.
dot equals.
You started with raw scores and you work your way down to the probability. On this one, you started with probability.
Okay, so that's pretty much the same equation you're using for all of these, you're just
So you
doing
have
it
to
either
put
forward
the
or backwards.
0.25
In
right
this case,
here.
you're doing it backwards because you have the Z score.
No,
Oh, 0.75 is the Z score.
Well, I have two notes.
Well, no.
Which one do you want?
Point
I want the
7
one
is the Z score
with
of 0.75.
the, you get
So you put
the,
in something like that.
Yeah, so, no. Okay, look,
where's
so
that? There you
go
go. You have it
from
written down here,
percentage
so I want
to
to.
the Z score,
I
you
have two
go,
notes.
Oh,
Remember?
it's just the percent.
Yeah, but.
yeah,
so I
0.75 is the Z
think We
score.
wrote it up here, but
There
you
you
didn't
go,
write
and
it down.
then you go inverse norm, and then the area.
So the question is,
Inverse norm.
how do we go from a
And then
percent
area,
backwards
I'm
to a
probably
decimal?
wrong,
We have to do
7.5.
this first.
I feel like I might go find.
And then you
Then
have
how do we go backwards?
0.27, right?
When you have
Oh,
Z
okay,
scores,
so
you
I-
have percentage, you should use normal to the X, but we're gonna go back.
Oh, did you do it twice?
No, you just put, after you do,
Yes.
after you do area, you just
Yep.
put paste.
I don't know, I think inverse norm you just.
You don't mess with it, you don't need to mess with anything.
That's the Z score right there,
Why
negative
is there a black
0.67.
box over there?
I don't know.
Guess what this one is?
0.67.
Yes.
You just click enter.
Now you're gonna use the same equation again,
Paste.
But it says left.
Oh, okay.
okay?
And then paste
And the
again.
one we're gonna find is that one, so you have no numbers there, and there. You'll have to do one on this side,
For the
one on this
norm,
side.
you have to
Next,
do-
next,
you have
what's
to
up?
do standard.
Yeah.
Standardization of the-
Okay, so, let's see, you know the mean was here in the center?
Okay, six.
What is it?
X.
1,026. You know what the Z score and probability are there?
Bless you.
Thank you.
What is the Z score? How many-
Okay, so that's the one.
Okay, perfect.
Got it.
Every time, every
So
time.
that's this right here, right?
What's the Z score?
Or for 0.75, so then you have to do the same thing to get 0.25.
You're on. How far
And
away?
then-
You're good.
Wait, look,
Okay.
what's that X
This
that you
score-
got, I mean, that Z that you got, so we put it over here, and now you're solving for X,
Somewhere.
which is
over
the
here.
score that they want.
Okay. You need to calculate the Z score, which you did, that's 1.39. Right?
Oh, yeah, so change the
Cool.
lower to.
Now we're looking for this person's percentile, yeah, right there. Okay, if they scored here, they scored better than that percent of the people. How do we figure out that percent? That would be if you had a percent, you went back to Z. This is a Z, you take 1%, that's a normal Z, yeah. Negative 13. And that's the top, so that's the upper.
And then for the lower, but -10.
Next,
Yes.
Wait.
what's up?
These are my answers.
What's up, Smarty Smarterson?
And more of these.
He's laughing, he's getting on the Smarterson.
Yeah.
I have an important question.
Some square, right?
Oh, yes, I actually have those,
It's done a really bad job of that.
What's up?
what did you say?
This guy right here.
What are 3 ways to assess normality of the deficit?
You did
have to answer that?
Once you get to the first one.
Are you asking me smarty make smarty things?
Yes.
Number 1?
Three.
Number 3.
So,
And I
How many
got
seconds
numbers
number
in it. And then you got 0 and 1, a totally different number, so you have.
For that was for 0.75.
and then
And then for 0.25 I got 17.66. Did you say my name again? Okay.
3 ways, what are the 3 ways to access the normality for set?
Didn't we talk about that?
I don't know.
We did, yes we did, yes we did, yes we did, right there.
And I got 6, 7, so I must.
Oh, okay, we found them.
Yeah.
Got it.
Oh, this wasn't a homework.
Okay.
Yeah, I know that.
I think so.
So either I'm like, the numbers are off, but they look right, or
Can't
I'm
hit 15.2 home runs, right? That would be weird.
Oh, I have to fix it.
How many hot dogs did you eat? No, that doesn't make sense. How many holes golf did you play? 13.6? Did you play 0.6 of a hole? I guess you could, like you tee off. Okay, that's the lower. Okay, what's the low end score? Okay, we're doing this in terms of Z-scores. What's the Z-score up here? 1.39. What's the Z-score down here? Negative infinity. How would you say negative infinity? It's negative? Not 0. 0 is not negative. Okay. Negative, really big number, like negative 10 billion. Negative 10 will do it.
Yeah, I could put this in my
It's just
block.
not negative 1, because negative 1 is only right around
What's a
there.
DO?
Negative 1, negative 2, negative 3. Here,
DO?
I'll show you the Z-score. So Max, let me show you.
What's that stand?
1 second, sir. So, hey, Max,
Use.
the Z-score tells you where you're at in the distribution in terms of standard deviations. Okay?
I bet it's.
If I draw you
That's
bell
not bad.
curve, right?
Oh,
Okay.
that's funny.
That's actually
Here's the
really
mean.
funny.
How far are you from the mean when you're on the mean? 0. These are Z-scores.
Are you putting them in?
Most of the time, 1,
Yeah.
2, 3 will get you to about there. Okay. How many standard deviations the other way?
I don't know.
This is negative 1, negative 2, negative 3. Are you okay with that? Okay, if this is negative 3, negative 4 is about here. Negative 5, negative 6. Can you see how negative 6 is really far off to the left? You can pick any number you want over here, as long as it's past like negative 4, you're good. Okay? Does that answer your question there, Max? Okay. All right, Mr. Curtis, how can I help? These numbers? 17, 24. What's up? Okay, so what did you put in? I said negative standard deviation, you put in a 0.5. 0 and 1. Because it's asking you what the standard deviation is. We're using 0 and 1 for Z-scores.
Can you check mine?
Yes. I don't really have to.
Oh,
They
okay.
already know. That's right. 4, is that 4?
No, that's a 3.
That's a 6, it's 3.
It's a 1, 7,
I agree with the 17. That is totally not 26. I think you multiplied wrong or you added wrong.
Let's see what we did here. 27. Oh, yeah, there's the
There she
problem.
goes.
It's by flying the one in Silicon Air.
Let's go like this. Let's see it. There, what if we go like this?
Oh, no, I didn't.
Oh, the negative, you use that negative, you can't use that negative. You have to use
Oh,
that negative. Now it's -10. Like that. It's seen as -10. It treats the minus and the negative as different.
I have a question.
Wait a second, this is our not T3 day, so we only have until 10:55, right?
Yeah.
Yeah. Okay, tomorrow we'll get more time. We need to start talking today about pennies and stuff.
What did you do for steak?
What's that?
I'm confused a little bit.
Oh, Debbie's catch.
I know, it's a bummer.
Okay, so.
Okay, that's irrelevant.
25%.
I'm asking you how to do this problem.
Those are standard deviations above the percents.
State plan due.
What's their real budget?
Is, 10.6
Yeah, let's
is our own
Where did you get that?
so it's 29%, right?
You didn't know that was back there.
I did, I just.
We're trying to find.
You got, you didn't know what 5 hours from that.
Yes.
What do I? Oh, am I right for the notes? But I'll tell you.
Yeah. Denver's farm,
The bell shape.
These are very.
It's the window, it's the window, it's like,
Like, that's how,
I'm pretty sure it's this thing.
it's this page, look.
0.25.
I can't see that.
Oh, yeah, probably not.
Okay, well, you're gonna need it, but anyways, that's it.
I don't even know.
Maybe
Maybe you're right.
Oh, yeah.
Maybe you're right.
Maybe I'm probably wrong.
I don't know.
There's 2 3s. How am I supposed to know?
Maybe try yours, and then if you're right, then I'm wrong.
I'm just gonna leave it blank. What did you do for? What did you do for the? For 5?
I was like,
And then paste it
Do I dot plot it? Is that my due?
I think so, I think we're supposed to see if it's bell shaped.
No, I think you're right. You're definitely right.
Me?
Yes, sir.
Always.
What's that?
Okay, deal.
You know what I mean?
Yep, you're correct.
I mean, we're supposed to see if it's bell shaped.
Okay, well, we can see if it's bell shaped through here.
Down the graph.
But it
It's not
says
gonna work here.
do,
You gotta,
so-
you're going a problem backwards. You have to consider what the thing is telling you and what you're trying to find, okay? So what's the information that it's telling you?
You're right. I have a question.
What are
for
they?
you.
What is that? What is that? Where does that fit into this?
Me?
I don't know.
Yeah.
You didn't tell me.
0.5 here, that's 0.25 and this one's 0.75. We're trying to get the scores that go along with that. You have to go backwards. You're gonna do an inverse now.
I have a question.
Maybe you have an enter.
Am I supposed to, for the due, make a dot plot? Is that what I'm supposed to do? Or
Yes, that would be, there's 2 things. You have to do the dot plot to do the empirical rule, like you did right here. What is 1, 2, and 3 standard deviations from the mean? And the other one would be just wrong dot plot. And it looks like-
Oh, this is part of the
Good deal.
notes that I
Oh, we need to get into pennies. We need to do penny stuff. Penny work? Want to help?
Sure.
Are you done?
No.
No? You're done with the front, right?
Yeah. Oh yeah, for instance, I'm using nothing when we did all this, so I need to get this note,
Okay.
and then I'll be able to do that.
No peeking. Grab a random penny.
Hmm.
Okay. No peeking.
Can I open my eyes?
Yep, now you can look at it. No peeking. Grab a random penny.
This one's kind
You
of
can take 4 if you want, just one. No
Red one
peeking.
now?
Grab a random penny.
Yeah, you can look.
Yep, you can look at it.
1977.
It's
So
2006.
You gonna vary? Dig down, baby.
That's
Get a penny.
fine.
One penny.
Between 5 and 10.
One penny.
It's a middle number.
Max, need a random penny. That row.
728,
Who is this, right?
Not a bunch of pennies, just one penny.
Wait, it's the same dude on every penny.
Is it?
Oh.
No peeking. Random penny.
Who is this guy?
No peeking.
It looks
Random
like
penny.
I feel so
One on the bottom,
dumb.
dude.
I don't even know who this guy
Wait,
is.
who's on your guy? Is it the same?
One random penny.
What year? 2006.
Who is this guy?
You ready?
I think
One
it's
random
Abraham
penny. No
Lincoln.
peeking.
I think it's
Whose
Lincoln.
is on yours?
I don't know, Jenna, they're all the
I think
same.
it's Lincoln.
But this
I need
is
to
one
have-
year. One year, subparent error for
2006, how old was I then?
Ugh.
I'd be 4.
Okay, folks. Hey, I need to interrupt you. I just wanted to practice with the Z stuff. There was a problem on the back too. We don't have time for it today. We got to cut short a little bit our time. I'd like to talk to you about my pennies. I have a lot of pennies. People give me their pennies now. Literally, yesterday, Mr. Armerding walked in the door. He walked over it. He dropped a penny in there because he found one on his floor, and he knows that I have them. I have somewhere just above $60 worth of pennies in here. About 6,000. It's a giant distribution of pennies. I've had you select a random penny because I'm kind of curious to know things about my penny distribution. The class that was in here the other day, one person, Resneet, got done with this thing so fast. She helped me out. We started drawing pennies out and putting X's up here to show you what my distribution looks like. One of the pennies somebody drew out was a 1960 penny. This is 1956, way down on the bottom. And then it ends over here on the far right at 2021. That's really, really new shiny penny. So let's start with you, Mr. Kurz. Can you read your penny on there?
1985.
I'm going to put an X for your penny right there. 1985. Olivia, you got yours?
2007.
What is it?
2007.
2007 goes right there. Sir?
1983.
1983. 1, 2, 3 goes right there.
1977.
Ooh, that's an oldie. 1977. Just about.
2006.
2006 is right here.
1993.
1993. Mr. Schick starts working at Meridian High School. Sir?
1988.
1980. God, I moved to Washington in 1980. Ma'am?
2007.
2012. That's a fairly new one. That goes way over here. And last but not least,
2006.
2006. So this is my distribution of pennies. There's some stories behind my pennies about when I acquired them. My college roommate, a guy that I'm actually going to go see during spring break, he lives down in El Paso. We were roommates in the early 90s, and he had a giant thing of pennies that he just gave me, and I've kept ever since. That's why you'll see a big glut of pennies right in here. Okay? And then when I started teaching stats, I wanted more pennies for this penny distribution thing, and so I went and acquired a lot of pennies about 10 years ago. You know, I've been collecting them ever since. And so this distribution is totally not a bell curve. Does it look like a normal bell curve to you? It should be fairly bimodal. There should be a big lump in the 80s up into the 90s, and there should be a lump over on the far right. Okay, now I could go through all these pennies, one freaking penny at a time, and put an X up there for every one, then I would know the exact distribution. Does anybody want to come in after school and do that?
How much money am I going to get?
Nothing.
I get all the pennies for
You'll
sure.
just know what the distribution looks like. You'll know about my pennies. That's all you get. What we do when we're stuck with situations like this, folks, is we sample. Sampling and making decisions based on samples is truly the art of statistics. That's what statistics really, truly is. It's working off of limited information. Who's going to win the next election? Are we going to go ask every single voter who they're going to vote for? Heck no, we're going to sample. Do I have to go to Mercedes-Benz and take every single SL5 that comes off the line, crash it at 35 miles into a 35 mile an hour into a concrete wall to know that they're safe? Boy, that's dumb. I can't wreck every car. I got to sell some, right? So what they do is the federal government, the U.S. federal government, makes Mercedes-Benz crash a brand new car into a concrete wall. Oh, wait, that's just one. Sampling one isn't dumb. They make you do it 3 times. That means if you're McLaren and you sell the McLaren F3 for like $150,000, you have to crash 3 of them 35 miles an hour head first into a concrete wall. Otherwise, you can't sell your cars in this country. Okay? Everybody has to do it. How many do you want to have to do? Well, as few as humanly possible because it costs a lot of money, right? So this concept of sampling is really what the art of statistics is. How do you sample? How do you know when sampling enough is enough? And then what can you do based on your samples? How likely is something to occur? If I just ask the people in the room right here today, I say, what's your favorite color? And she says pink and blue and yellow and purple and blue and red and orange, right? Is there a good chance that whatever the favorite color is here, it's the same for every student in the school? Will I get the highest percentage? I don't know. You're just a sample size of a whopping 9 people. It's not very big. How many people do you have to sample to feel good about your results? Again, this is the art of statistics, making decisions based on limited information, sometimes really, really small limited information. My favorite example of really limited information is if you're the federal government, the military, if you're Joe Biden, and you go to your Joint Chiefs of Staff and you say to them, hey, Joint Chiefs, we've got nuclear bombs, right? They go, yeah, we got nuclear bombs. Have you tested them? When I push the button, is it going to blow up? They go, yeah, totally. How do you know? Oh, because we had to test them. Every time they test one, it costs about $1 billion, not $1 million. Okay, it costs a schnot load of money to test a nuclear warhead. You have to refine the uranium or plutonium or whatever the other kind of uranium is, depleted uranium, right? You got to build the bomb. You have to take it somewhere, bury it underground far enough. It has to be safe. It costs a lot of money, right? How many do you have to test so that when you push the button, you can be like, I don't know, how confident do you want to be? Do you want to be 95% confident that they're going to blow up? 99% confident? Is 99% good enough for nuclear bombs? You know, is 99 a lot? If you made it to school alive 99% of the time, is that acceptable? That means you're going to die once every 100 days on your way to school. So let's say you've probably died like 6 times from the time you started as a freshman up till now. You know, so what is a high enough percent? And that's part of the art of statistics too, is trying to determine what's enough, what's good enough. In algebra, it's super easy. Solve for x, get an answer, done. Yes, I got it right. And statistics is harder because there's sometimes no right or wrong answer, all right? And that makes things a little bit sketchy at times. How many of these pennies do I have to put up here so I know exactly what the distribution looks like? Do I have to do every single one of them? Probably not every single one of them. But that's why I have the pennies. Well, this concept of sampling, something really cool happens when you take samples and you start averaging them. If I took your penny, and 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 your penny, I took all 9 of them, added them up, and divided by 9, I'd probably have a better idea what the real mean of this data is, right? You follow? Okay, let's do some samples. Man, whoops, wrong one. This is my wasted pennies. We don't sample twice. We only sample once. You need 4 more pennies. 1, 2, 3, 4. 4 more for you. 4 more for you.
1977. I got 2 1977.
What are the chances? I got 2007.
Oh, no.
4 for you.
2003. Is that the year you
4
were
for
born?
you.
Is that the year you were born? 2003.
Yeah.
4. Oops, did I get too many? I didn't.
Lame.
I
One,
can't
two,
even
we need that crusty one.
Can you read this?
Okay, folks, now you don't have 1 penny, now you got 5 pennies. Here's what we're going to do. You're going to take your 5 pennies and you have to find your own personal average. You're going to want to take calculator, type the 5 numbers into the calculator and add them up and then divide by 5. We're looking for the average of your 5 pennies. Average of your 5 pennies. Ooh, if you have one that's really tough to read, I have a loop up here. Do you guys know what loops are? Check it. This is cool. I really like my loop. So if I got a penny like this and you can't see it, you can take the loop and go like this. Now I can see that that says 1983. So if you need the loop, let me know.
I see the word.
Yes, you can have the loop. Loop it up.
I might.
We're looking for your average of your 5 pennies. Miss Carrillo, you got a, what did you get for your average? 2005? 2005, really? Wow, check this out. You're right there. I need a favor. Can you take the small bowl here, put your pennies in the small bowl, and then as I give people do it, can you collect the other ones in the small bowl? Not the big bowl, no, in the small bowl. Anybody else got an average? Yes, ma'am. 2006? Boy, you're extreme.
Who said
Look at that. Wow. Yes, sir. 1985? Okay, who else got one?
1990.
1990 is right here. Jenna, you got one?
Yep, 2004.
2004.
That evening.
1979.
1979. Seriously?
Yes.
Wow, that's the smallest one I've had yet. Yes, ma'am.
I win again.
2005 goes there. Dane, 89. I got my first college degree in 1989. Sir?
1986.
86. I was a junior in high school.
What year?
86.
Wow.
I got dunked on in 1986 by a guy who played in the Pac-10. Nice. Yeah, I should ask Durkee this story. He'll tell you about Chris Chandler. He played against Chris Chandler from Everett. Chandler played in the NFL. He was just all-world basketball player and athlete. So Clayton started in a Super Bowl winner for the Falcons. Okay, anyway, that goes back. There, those are my sample ones, right? Okay, this stuff over here, I'm purposely keeping it aside. There's actually not very many in there compared to there. I think there's only maybe about $2 to $3 worth right here. So I got a lot of pennies. All right, so I want you to see what I marked up here. The X's were single pennies. 1 penny, 1 penny, 1 penny, 1 penny. I got a lot of 1986 pennies right there. I have a bunch of 2007 pennies as well. You'll notice I didn't put an X. It's an X with a bar over it. Why is that an X with a bar over it? Because that's not 1 penny. That's the average of 5 pennies. What happens when we sample? Whenever you sample and you start taking the averages, the graph starts to look a little different than the original graph. Does it look like the original graph? Anybody got a wild guess what happens with the green graph if I start putting more X bars up there? Doesn't quite look like it yet, but it's on its way. Say again? It totally does make a bell curve. It makes a normal bell curve. We don't have time for it today for me to prove it to you, but tomorrow when we show up, I'm going to prove it to you. I'm going to do something where I've got a computer program and it takes samples and it'll graph the samples. And after it graphs all the samples, you're going to look at it and you go, yeah, that's pretty much bell curve. Because I can do like hundreds of thousands of samples and it makes it really cool. So there's a couple terms that we need to know, some words that we got to get out of the way. So make sure you grab your notes. The notes look like this, right. What do I do with my notes? I got stuff all over the place up here today. Oh, you got mine. My new ones? Let me see. I think. Yep, totally. We're on the day that says March 15 to March 19, 7.1 sampling distributions. Sampling distributions looks like this. Okay, talking about sampling, the art of sampling. Some terms that are going to be worth knowing. The first one is parameter. I always like to use yellow highlighter because that's an important word. The second one is statistic. You're like, statistic? This is a statistics class, right? Yeah, we're doing statistics. What does that word mean, statistics? Isn't it just like a whole bunch of numbers? It's very specific. There's a difference between a parameter and a statistic. Okay, I like to circle the first letter in each one. I circle the letter P and I circle the letter S. A parameter, let's zoom it, make it bigger. A parameter comes from a population. Oh, isn't that nice? Parameter, population. They both start with the letter P. A statistic comes from a sample. When we're talking about the word statistics, again, it's the art of sampling when you can't do a census. A census is when you sample everything. There's no sampling. You're just getting it all. Our U.S. Constitution says that we have to do a census every 10 years. We have to count every single person in the country. You're not allowed to use statistics. You're talking about parameters in that case because it's everyone, okay? How many people are actually alive in the country right now? That's a parameter. That's everyone. A statistic would be if I took a sample of people and then I guessed based on that sample. That's statistics, okay? So anyway, statistic, sample. I like to draw myself a big circle, and in here I write population. Population's everyone. The students at Meridian in the Meridian School District makes up a population of people. What we do is we take a sample from within the population and then make guesses based on it. Educated guesses. There are some variables that are going to come up for these two. When we're talking about populations, the mean of an entire population, we use the Greek letter mu. It's pronounced like the cat would say meow, 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 meow. That sounded more cat-like, didn't it? So, mean of a population is called mean, but we pronounce it mu, and we use that letter. For a sample, the mean is an X with a bar over the top. We use Greek letters for population. We use English letters for samples. There will be an exception because you won't like the last one. For standard deviation, if we're talking about entire population, that's the Greek letter sigma. It looks like an O, and he's got a visor sticking out. You know, you guys totally see the visor hanging out there over the top? I feel like drawing a face in there now. Would he be a happy face or an angry face?
Maybe like a serious face.
A serious face, because it's statistics, it's serious business.
I think we'd be happy.
A happy one. The standard deviation over here, we use S sub X. Again, English letters for the sample. Population, sample. This is where it gets a little bit weird. We have proportion for both of these. Proportion, I hope you're comfortable with, is just a fancy way of saying percent. What proportion of the people drove to school today? That's the same as saying what percent drove to school today. Proportion, percent, one and the same thing. When we're talking about a population proportion, the Greek letter is the letter pi. However, pi has been co-opted by geometry and other forms of mathematics. We don't really use pi. It's the statistical letter that we use in stats, but we don't use pi. You guys know what pi gets used for?
Eating.
Pi, eating. Do you know that Pi Day just happened last Sunday?
Yeah.
I freaking hate Pi Day.
What?
Pi Day is stupid. Can I show you why Pi Day is stupid?
No, you're gonna ruin it.
Not like it's like this.
Yes, I do.
You have pie.
I have cake.
What is it?
Circle.
Is it pi? Does it look like a pie to you?
I mean,
If I walked up to a third grader and I said, is that a whole pie? Seriously, is that a whole pie?
I mean, yeah.
There's a whole pie. If I go into your pre-calculus class and I say, is that pi? You got to go, no, Mr. Schick, that's not pi. That's 2 pi. The third grader standing next to you looks up and goes, that's 2 pi? What are you, high? I don't see no 2 pies. That's pi. It's just 1 pi. No, that's 2 pi. You want to see pi? Here's pi, right? Isn't that pi? Am I kidding?
That's a sunset.
No, this is 2 pi and this is pi. And then the third grader looks at you and goes, you're so stupid. That's half a pi. And then you have to go, no, kid, you don't know anything.
That's half a pie. Am I lying?
It's slice.
Okay, who took pre-calc last year and knows what I'm talking about? You know what I'm talking about, don't you? Yeah, because you learned how to measure in radians. In radian measured, folks, this is 2 pi, that's pi, and that's half a pi. That's dumb. I prefer the Greek letter tau. Also, because the Greek letter tau, which is double pi, 6.28. See, this is tau. That's half a tau. That's a quarter of a tau. Doesn't that make so much more sense? I hate that we use pi instead of tau. So tau is way cooler than pi. And I just freaking hate Pi Day. The other thing I really like about tau is it's 628. My birthday is 629. So my birthday is tau day plus 1. Makes it easy for people to remember. There's only a couple more shopping months until my birthday, by the way. Just a reminder. You know, it's what, March now? April, May, June.
Don, we're gonna miss it.
3.5 months.
Yeah.
It's all right. I'm always here. You just show up here on my birthday. I'm sure I'll be here if you wanted to, come bring something to Mr. Schick. Maybe a cupcake. Okay, anyway, there's my rant about pi, which I think is dumb. Okay, so we use pi for proportion. It's a Greek letter. Over here on this side, a proportion sample, we do P with a little hat over it. It looks like it's wearing, quite literally, a pointy little accent of a hat. Okay? That's a sample proportion. Just like mean as a sample gets a little X, he gets a thing over the top too as a percentage. So if I sampled in here, what's your favorite color? What percentage were blue? That would be a P hat. Sample percent. The reality is we don't use pi because pi is 3.14 and got co-opted by other math, so you can put an X over pi. What we do instead is we just use a P without a hat. If you see a P without a hat, that is a population proportion. Knowing whether something has a hat or does not have a hat becomes a big deal when you're writing your notation out, right? If I say, the percentage of P is 13%, if I write P equals 13%, people have the favorite color is blue. I'm talking about everyone, the whole population, as opposed to just the sample. All right, let's take you through some examples, see if you can pick out the stuff here. So we're going to identify the population parameter and the sample and the statistic in each one of these following things. A pediatrician wants to know the 75th percentile for the distribution of heights of 12-year-old boys. So he takes a sample of 50 patients and he figures out that Q3 is 56 inches. There are 4 things that we've identified in this problem. What we'd like to know is, first of all, who's the population? And what's the parameter that goes with that population? Who is the sample? And what is the statistic that we gleaned from that sample? See if you can fill those 4 in. I just had something really cool happen. It doesn't happen very often. I drained my pen. And I need to get a replacement. Ink cartridge. I love my purple pen. All right. Think we're ready for some answers? I won't pick on you yet. I'll pick on you in the next one. All righty, here's how this works. The population in this case is 10-year-old boys. The sample is the 50 patients. The parameter are the heights of the 10-year-old boys. The statistic that he gleaned from his stuff was that Q3 was equal to 56 inches. All right, one to try on your own again. Inside of this story, there is a population.
there is a parameter. Inside of this story, there is a sample. And there is a stat. See if you can fill them in. 10 minutes. We're going to get far enough in 10 minutes today. All right. Anybody want to volunteer for what they think the population is? Oh, Wes, you volunteering? What's the population?
Sure, 12 to 17-year-olds.
This is definitely 12 to 17-year-olds in the United States, if we want to be really specific, in the U.S. Okay. Ooh, what about this sample? Who's the sample in here? Harmon, you haven't been here? Harmon, let me hear from you.
1100 to 12 to 17-year-olds.
This is the 1102 in the sample, yeah, that they actually went and they checked on. Here's an easy one. What's the stat? Oh, actually, maybe it's not easy. Maybe it's super hard. Olivia, you want the super hard one?
71% said yes.
71% yes. Anybody want to take a stab at what they think the parameter is in this case? Because it's like invisible. It's not there. That's super frustrating, isn't it? Think you know, Matt?
Also have a cell phone.
What's that?
Have a cell phone.
I would not say those with a cell phone. Nope. Nope. It's this, folks. It would be, so the Pew Research Center asked this many 17-year-olds in the United States if they have a cell phone. It would just be, not that they have one, but it's the, do they have a cell phone? I can't spell the word cell. You could also argue it's the true percentage of people that have a cell phone, yes or no, but it's the question. That's the parameter of interest. The parameter is what percent really has a cell phone. Okie dokie. How do we feel about that? Fantastic. Parameter, P, population. Statistic, S, sample. And again, statistics is the art of taking samples. And so we'll start looking at that tomorrow. Hey, I wanted to tell you some things about your homework and let you know what's going to be expected in the next couple of weeks.
Wow, only 2.
This is week 3. You're going to have week 4 and you're going to have week 5. Okay? I have been giving you 3 assignments per week. You're only getting number, I think it's 39 and 40 this week, right? I gave you 2 assignments. Next week, you're only going to get number 41. That's it. Next week, 1 assignment. I will give you the review as well, but I like to think as the review really going there. And then the last day that we're in here, we're going to take a test. It'll be on chapter 2 and chapter 7 both. That's kind of what the next 3 weeks look like. We're right here right now. Now, some of you, this homework is piling up on you. I don't want to like name anybody or pick on anybody or show you what it looks like. You ready? This is my stats class right now. Here's all the assignments, and every one of those blue checks is somebody who's got one done. So you can kind of take a guess, like, how many do I have points for? How many do I need to get done? I fully expect you to be behind. So for the 1, 2, 3 people that are all the way caught up right now, if you're one of the 3 people, you're well ahead of the curve. I don't expect you to have them all done, because when I give you an assignment, I expect you to screw up, and I'll tell you what's wrong. And then, folks, this is like, I treat it like a college class, because this is a college class. It's your responsibility to make sure you ask for help. Find time to ask for help, get help from somebody else, hit me during my office hour, whatever you need to do. If you're fine sending notes back and forth on Google Classroom, that works great for me. I try to give people decent feedback, but sometimes it's tough, So it's on you. Get help, get it fixed, turn it in. You'll get your points. You'll get full points as soon as you get it done. Okay? Fair enough? I get it. If you're behind, I expect you to be a little behind, maybe not all the way behind, but get them done, get them turned in, you'll get your points. Okay? The more you procrastinate, the harder it's going to be. So, and again, this is what our next 3 weeks look like. And then I won't see you for a month and a half, because we'll go 5 weeks of school and 1 week of spring break where we won't be here in this class. And then at the end of the year, we'll basically finish with 4 weeks. It's actually 4 weeks and 2 days. You get 2 more days than the other section does, because you're special, right? Any questions for me? Anything at all? Okie dokie. Oh, big stretch.
Those extra 2 days if we graduate on the 9th.
Hey, oh, that's right. You won't even be here. Dane will be here, right, Dane? Are you a senior? Okay, you're not a senior, so you'll still be here. You know what I just realized? I keep walking up here in front of this thing. This is my camera right here that I actually have on the notes. So, Miss Cruz, are you watching this today? What do you think? Will she watch it? Okay, well, it's out there. It's out there for the world to see now.
You did your job.
I tried. I'm trying to do my job better, because I'll tell you, the stuff I put out there last week was crap. So
It's just Olivia's head.
it's crap. The stuff I put out there today was way better, I hope. And if not, you can put your comments.
Comment down below.
You can put your comments where, yeah.